Welcome to Brain Vision.
All right. So in this problem, so initially we have a capacitor, and then we slide a copper slab into this between the two plates. So this is the copper. So you should know that the copper basically it is conductor. So the area of the capacitor is A, and the separation is D. The thickness of the copper is B. So due to the conductance of the copper, so basically if we slide this copper in between the two plates, then the effective separation of the two plates will become D minus B. Okay, so the new capacitance will become epsilon naught A over D minus B. Okay, so the value is 0.708 picofarads. And for part B, we want to know the energy ratio before and after. So we know that the charge is actually fixed on the surface of the plate. So the energy stored on the capacitor equal to, so before we sliding this copper, the energy is half, actually 1 over 2c times q squared. And after is E prime equal to 1 over 2c prime q squared, because q does not change, q is fixed. Okay. And so we can find out the energy ratio E over E prime equal to C prime over C. All right. So we know C. We can actually find out C by just utilizing. So C prime is epsilon naught A over D minus B, and C is epsilon naught A over D. Okay. So this will give you the result 1.67. And for part C, we want to know the energy difference before and after. That is the work, basically. So the work equal to E prime minus E. So we already know the expression for E prime, which is 1 over 2C prime Q squared minus 1 over 2C Q squared. So this gives you negative 5.44 joules. And for part D, as we can see that this work is actually a negative value. So it means that the system tends to suck this slide. Sorry. The system tends to slide this to suck this copper into between the two plates. So basically, there is a force to suck this copper slab into this space. So it is sucked in actually. Okay.